Welcome to qnawire.
In this problem, we need to find the angular velocity of the rod upon impact. So, I have here a sketch of the problem. So, a rod with mass m hits the frictionless surface with a velocity v1 and no angular velocity. So, the impact produces an impulse at point A, as you can see in the second part of the diagram, and causes the rod to rotate at angular velocity omega and the mass center to move with the velocity v. So, as you can see in the third part of the diagram. So, the velocity v has components vx and vy. So, applying the coefficient of restitution, so we'll have, v ay is equal to negative e va1 vay2 is equal to negative e vay1. So, this is just equal to e v1 directed upward. Now, writing an equation for the horizontal component, so we'll have, 0 plus 0 equals m vx. So, this tells us that vx is actually equal to 0. Now, writing an equation for the vertical velocity, so we'll have, vy equals ev1 minus L over 2 omega sine beta. So, since point G is at a distance L over 2 away from point A, and since the rod forms 30 degrees, makes 30 degrees, an angle of 30 degrees with the vertical. So, that's why we have this equation. Now, solving for the moments about point A, taking the clockwise direction as positive, so we'll have m v1 L over 2 sine beta plus 0 equals negative m vy L over 2 sine beta plus I omega. So, since this is a rod, so the equation for the moment of inertia would be, I equals, 1 over 12 ml squared. Now, substituting this and also the equation for Vy in this equation, so this will become, m V1 L over 2 sine beta equals, m times L over 2 omega sine beta minus e V1 times L over 2 sine beta. Then, plus 1 over 12 ml squared omega. So, further simplifying the equation, so we'll have, m v1 L over 2 sine beta equals, m L squared omega sine squared beta over 4 minus e m v1 L sine beta over 2 plus 1 over 12 ml squared omega. So, further simplifying this one, so we'll have, for the left hand side, we can combine, m v1 L over 2 sine beta plus e m v sub 1 L over 2 sine beta equals, for the right hand side, m L squared omega sine squared beta over 4 plus 1 over 12 ml squared omega. So, still further simplifying the equation. So, for the left-hand side, we'll have, so m v1 L over 2 sine beta 1 plus e equals, so for the right-hand side, so we'll have 3ml squared omega sine squared beta plus ml squared omega over 12. So, the left-hand side will become, so, multiplying 12 on both sides. So, the equation will become, so 6. And then, canceling out m. Okay, so the equation will become, so 6 vi sine beta 1 plus e equals omega L times 3 sine squared beta plus 1. So, solving for omega, so omega is equal to, so 6 sine beta 1 plus e over 3 sine squared beta plus 1 multiplied by v1 over L. So, substituting the values, so this will be, so 6 sine 30 degrees times 1 plus 0.8 over 3 sine squared 30 degrees plus 1. So, multiplied by v1, which is 2 meters per second, over the length, which is 1 meter. So, this is equal to, so 6.17 radians per second.